Okay, we're at gotomath.com working some calculus. We'll go down to concavity. I believe we're doing 8-2. It says find the inflection points. So at this point, you should be catching on if you've been working some of these problems. Now this one here says round to 2 decimal places if needed. I think because we got this 0.1 out here. And we got a nice little graph here that we could get an idea at least what it is. That looks like negative 1 point something or another. Now they're on the inflection points, 1, 2, so a little more than 1, right? Little. Okay, so we're actually looking for these points right here, but in order to find these points, we need to test for the concavity. Okay, that's kind of important also. Okay, so let's write this. Let's write this down. Got that written down, and round to 2 decimal places if needed. We'll need to keep that in mind. Alright, so let's move over to the whiteboard. We have f of x is equal to 0.1 x squared minus 4, and that's squared minus 2. So the first thing we'll want to do is take the derivative. So we bring the 2 out front, and that's 1/10. And let's see, try to remember this. Let's see, 1/10, 2 over 1/10 is 1/5. 2 times 0.1 is 1/5. Rewrite. I hope I got that right. I'll check that here in just a second. And then derivative of the inside is 2x, and the derivative of constant is 0. Alright, and let's see. The next thing I'm going to actually do is, since we're going to be taking the second derivative, let's go ahead and just multiply this 2x across and the 1/5. And okay, so this actually is 2/5 x. So this is going to be 2/5 x cubed, and then this would be 2/5 times 4, which is 8/5, so minus 8/5 x. Alright, so we're going to take the second derivative of that. Be a whole lot easier than using the product rule. It'd be kind of ridiculous. Alright, so bring the 3 out front, so we end up with 6/5 x squared, and then minus 8/5. Alright, then what we'll do is set this thing equal to 0. Minus 8/5, and solve for x in this problem. So we can actually get rid of this 5 if you want by multiplying through all the way across by 5. It's a little extra work. Why don't we just do that? Here, we'll do that right here. And so we end up with 6x squared minus 8, right? Multiply that by 5, and that by 5. Okay, bring the 8 over. You know what? Since you're a grown-up, we're going to skip some steps. So if I brought the 8 over, then divided by 6 and square rooted everything, here we won't skip everything. You'd end up with 8 square root of 8 6. Make sure you write plus or minus, okay? And of course, we can kind of simplify this down a little bit. 2 goes into 8 4 times, 2 goes into 6 3 times, but the square root of 4 is 2. And you can't square root 6 or 3. That'd be the square root of 3, right? Okay. Okay, so, well, we're done on that anyway. That part of it. Now what we'll do is a number line. Let's do the number line. I forgot, are we looking for inflection points, or what are we looking for? It doesn't matter. Let's see, negative 2 over the square root of 3, positive 2 over the square root of 3. I meant to put a square root there. Alright, well, we got a test point of 0. That's definitely 1. And the question is, what is 2 over square root of 3, the decimal representation? Let's see, let's find out here real quick. 1.15. So this is 1.15 1.5 approximately, so we'll pick 2 as our test point, and how about -2? Now the reason we're doing this is to change. It's a good exercise we need to look at the concavity of the graph to determine if this will be an inflection point. Okay. Now I'll just tell you that it obviously is, but we need to kind of look at the concavity of the graph. So we take -2. We go f double prime of -2. Now all we care about is if this is negative or positive. So let's look at this right here. Let's actually you can multiply through by 5. Kind of look at it that way if you want. No, we can't do that. Never mind. Okay, so let's do this. So we end up with -2 squared is 4, and 6/5 times 4 is that greater than 8/5? That's the question. And so we got 6 times 4 is 24 over 5, and 24 over 5, is that bigger than 8 over 5? And that means 5 goes into 24 more times. 5, right, so that would be positive number, right? So this is positive. Man, we got to ration that out or what? Positive, that means it's concave up. Okay. Then what we're going to do is look at f double prime of 0. So we plug 0 in. Well, obviously that's a negative number, right? So that's negative. A negative. So we know it's concave down. And then of course 2, plugging 2 in, it's not going to matter because this is square right here. You know, you square a negative, you just get square. So we know this is positive, and it's concave up. So as we can see here, this number here is in the domain, remember, of our original function up here. Okay, this is in the domain of the original. That's important to know, okay, because inflection points can't occur at a vertical asymptote, right? So that's important. And plus we have a change in concavity here. There's a change here, right? So we're going to get an inflection point here and an inflection point obviously here.